Okay, so we continue our discussion. Okay, now last time we have mentioned we add calcium carbonate, which is a impurity in purpose to the extraction method, because it try to lower the melting point of the ore. The second one is it can help to remove the impurity, which is mainly silicon dioxide in our compounds. Okay, now so today we're trying to write down the chemical equations from the work equations. Well, here shows step 1, we have carbon, oxygen, and carbon monoxide. Okay, so first we write down the species, okay, like this, and the physical state. So as joint covalent structure, carbon of course exists as a solid, and oxygen of course exists as a gas. So similarly, because CO is a molecule, so they should exist as a gas too. Okay, now next one, from the left hand side you can see there are 2 oxygens, right? So on the right hand side we also have 2 oxygen to balance the number of oxygen. This is the first point. Then we can see on the right hand side we have 2 carbons, so we need add another carbon to balance the carbon number. Okay, but you should be careful as the red one is correct, but what about if you write down something like this, carbon 2? Well, this is not correct, because if you write down carbon 2, that means you are trying to tell others carbon exists as a molecule, which is not the truth, right? So make sure you won't make this mistake. Well, very good, we finished. The second one is carbon monoxide, which is a gas, react with iron-free oxide. Okay, so I hope you still remember. Free here indicate the charge of cation, that is iron, free iron, combined with oxide iron. Well, you can see the formula is Fe2O3. So back to our questions, Fe2O3. Well, as a ionic compound, because the combination of a metal and a non-metal, this is a solid, right? Finally becomes CO2, gas for sure, and Fe, solid, right? Well, next we try to balance the number of iron first, right? Okay, here shows on the left hand side we got 2 Fe, right? So on the right hand side we also have 2 Fe. On the left hand side, each carbon monoxide will take away 1 oxide ion from the ore. Okay, so the number of CO should be 1:1 in ratio. So here we got 3 oxide ion, so we should have 3 CO. And here we can see we balance the charge, right? Oh, sorry, we balance the number. Well, next is, okay, in our earth, okay, the lead and zinc, they often exist as metal sulfide. Okay, here shows metal sulfide is S2 minus. Okay, now if we want to extract metal sulfide, then 2 steps will be involved. Okay, 2 steps. The first step is the sulfide should be changed to oxide while heating in the air. Okay, the next one is, okay, the second step is the metal oxide will be extracted, okay, by the method we mentioned above. Okay, so here is the work equation that you should memorize. Okay, the metal sulfide more generally is metal sulfide. Okay, react with oxygen to form metal oxide and sulfur dioxide. Okay, very good. So that's how the reaction undergoes, right? First, we use zinc sulfide as an example. So again, write down zinc sulfide which is a solid because it is an ionic compound, and oxygen, well, very good, O2, to form zinc oxide, which is a solid, and SO2, which is a gas. Okay, so from here you can see the number of oxygen is not what we want. Okay, on the left hand side we got 2, but on the right hand side we got 3. So in case we try to balance the number of oxygen, left hand side should have 3 oxygen atom, right? Something like this. It looks weird, but it is true, right? So here we have balanced every substance, but in examinations we do not accept, okay, the coefficients like this in fraction or in decimal places. We do not accept. So for the whole equation we need to times 2. 2, 2, 2, and O2 become 3. Here shows we finish balance the equation, right? Well, next is zinc oxide heated with coal, which is carbon, to form zinc metal and CO2, a gas. Okay, so you can see on the right hand side we got 2 oxygen. So here we got 2 zinc oxide, right? To balance the number of O, and then we balance the number of zinc. Well, then we finish the job, right? Now it's your turn, okay, to try the lead-2 sulfide, okay? And you can pause the video first and do your work, and I'll tell you the answer. Oh, is something wrong? Yeah, because you can see both zinc ion and lead-2 ion, the charge is the same, so their coefficients should be also the same, like this, okay? Well, next one, let's complete the checkpoint. So again, you can pause the video and complete your job first. First, you are going to name the gaseous product, okay, in stage 1. So this is sulfur dioxide, and the chemical equation evolve. Okay, so I don't want to waste your time, and let's write the answer directly. Like this, right? The next one is describe with chemical equations how zinc extracted from zinc oxide. Well, first, let's write down the equation first. You can have 3 choice. The choice 1 is by heating zinc oxide with carbon, and the equation is zinc oxide, carbon, to form zinc metal and CO2. Very good. Okay, the second one is by heating zinc oxide with CO. Then the equation will be even simple than before. Okay, but keep in mind that you cannot use hydrogen because no reaction undergoes. Okay, no reaction undergoes. So this is what we have come across. Okay. Okay, now, so maybe here you can get the idea, right? In case there is a more stable oxide, or compounds, okay, then that means more reactive metal. Okay, so this is a very important idea. So please keep in mind of this idea. Okay. Well, next one is the final extraction method. Okay, this is called electrolysis, the molten ore. Now, molten ore, molten is necessary. Okay, so again, you must remember. Okay, this is target for those most reactive metal. They are very stable. Okay, so we need to use the most extreme method. Okay, now here shows. Take an example. For example, magnesium oxide. Actually, this is composed of magnesium ion and oxide ion, right? Well, in order to turn the magnesium ion back to magnesium metal, we need to add 2 electrons for it. Okay, so where comes the electron? Is from the negative pole of the battery, right? So after you molten, okay, after you molten the compound, molten oxide, that means from the test of previous exercise, you learn that there are mobile ions, okay? And the magnesium ion is free to move, okay? So they will attract to the negative side, okay? The attractive to the negative pole of battery or electrode, because attraction undergoes between opposite charge substance, right? So the magnesium ion will receive electron and turn back into magnesium metal. Okay, and in our situation, we use aluminium. This is the same, right? The aluminium ion will come to the negative pole and become molten aluminium, turn back into the metals, right? Well, on the other hand, how about the oxide ion? Well, the oxide ion, of course, they will go to the positive side and lose their extra electron and turn back into oxygen gas. So the idea is very simple. Just depends on what kind of ore you are using. Just turn back into element. It's okay. Here shows the sodium chloride will turn into sodium and chlorine, while the aluminium oxide will turn into aluminium and oxygen. Okay? Now, you can see actually electrolysis can be used to extract not only reactive metal but all metals. It is wonderful, right? But the point is, we do not use it in all situations because it involves heating and electrolysis or electricity, which are expensive. Okay, this is the most complicated and expensive method. That's why, if possible, we will choose other possibilities. Okay, can it use to extract less metal? Yes. Okay, yes. But why not? Why not is because it is the most expensive method. Okay, consume fuel for heating and electricity. Okay, so you can see among this table, okay, wow, there is something wrong, right? Yeah, this is something wrong. Okay, okay, the electrolysis method can be applied for all metals. Okay, while heat the ore with reducing agent, only limited for those zinc or less reactive metal. Heat the ore with carbon, is for mercury and silver, gold, and physical extraction is gold only. Okay, the rest of them all are not suitable. Like this, okay? And for the chemical equations, I hope you not only memorize them, but you can derive them to write it out by yourself, okay? By understanding, but not memorizing, okay? And this is the same as what we call the reactivity series, so please remember that, okay? Well, next one, which metal exists in free state? Free state means do not form compound, so the answer is C. Oh, okay. Again, you can pause the video for your work first, okay? The second one, which of following can be reduced by heat alone? Okay, don't forget alone. This is silver, mercury, calcium, no, so the answer is boy. Third is following gas produced from lead to sulfide, right? Now, you have two choices, okay? Carbon dioxide, yes. In case you use carbon or carbon monoxide for extraction, carbon dioxide will form. Oxygen, no. Sulfur dioxide, yes. So the answer is boy. Finally, extract sodium is correct. So, boy, heater underwood, no. Dog, no. Only A and C looks correct, but the difference is one is aqueous solution, one is molten. So our answer should be C, molten. Okay, aqueous solution doesn't work. Okay. Okay, so this is what we have learned in previous session. Okay, hope you enjoy it. Find me or send for any help if you got any difficulty. Okay, see you.